this video, we will be discussing about maximum sum of three non-overlapping subarrays. Given an integer array nums and an integer k, find three non-overlapping subarrays of length k with maximum sum and return them. Return the result as a list of indices representing the starting position of each interval. If there are multiple answers, return the lexicographically smallest one. So what they are saying is that in the input, we are given an integer array nums and an integer k. Now what we need to do is that we need to find out three non-overlapping subarrays of length k, right? From this nums array, we need to find out three non-overlapping subarrays of length k such that they have the maximum sum, right? We can write down with max sum, right? So they are saying non-overlapping subarrays, total three, length should be k with max sum, right? So basically in this nums, we need to find out three non-overlapping subarrays of length 2, which are having the maximum sum. So now what are all the subarrays of length 2 over here? One is this, other is this, other is this, and so on. But hold on, these subarrays have to be non-overlapping, right? So if I am considering this as a subarray, the next subarray has to be this one, if this is my answer, right? So this non-overlapping we have to keep in mind, right? And we need to identify such subarrays with the maximum sum, right? So if I, let's suppose, take one this subarray, one this, and one this, what will be their sum? This will be 3, this will be 3, and this will be 6. So total will be 12, right? But if I take this subarray, so this sum will be 3, and I take this subarray, this will be 8, and if I take this one, then this will be 12. So the total sum will be 23, which is larger as compared to the previous one, right? So these three subarrays are our answer, right? Because they are having the maximum sum. Now what we need to return is we need to return the starting indices of these three subarrays. So this subarray is starting at index 0, this is starting at 3, and this is starting at 5. So our answer has to be an array containing the starting indices of these three subarrays, right? So this is what we need to do, right? So see what we can do. If I am at this particular index, I am having two choices. Whether there will be a subarray which will start from this index or it will not start from this index, right? For this index, I am having two choices, whether I start a subarray from this index or I don't start a subarray from this index, right? So basically, I am saying that I am at an index 0. For this index 0, I am having two choices. One choice is that I include it, basically I start a subarray from here, and one is that I exclude it, that I move on to the next index to start my subarray, right? So when I have included this, basically when I have started a new subarray from index 0, then from which index can I start my next subarray? From the index I plus k. Why? Because our subarrays have to be non-overlapping. If from index 0, I have considered the starting of a subarray, then it has to be of length k, right? So then that means the next subarray will be started from the index I plus k, that is 2, right? I cannot start it just from the next index, right? Our subarrays have to be non-overlapping, right? So whenever we are starting a subarray from an index I, then the next index will be I plus k, right? So when I have taken this index 0, my subarray will be this much. So my next index will start from index 2, which is nothing but I plus k. 0 plus 2, 2, right? So now here my I will start from 2. And if I am not starting a subarray from this index, then I can simply move on to the next index and I can decide for it whether to start a new subarray from there or not, right? So in that particular case, I will simply do I plus 1. I will go to I equals to 1, right? Now again, for these two indices, I have the similar choice, but hold on. Here I have started a new subarray. Then that means one subarray I have already considered for this path. So when I am at I equals to 2, from the further paths, I need to identify two more subarrays, right? One I have already identified here. So along with this index I should also keep a variable to track the count of subarrays that I have considered till now, right? So initially when I was at index 0, my count of subarrays is 0, right? The number of subarrays that I have considered till now is 0, right? When I have started a subarray from index 0, so next my index is starting from I plus k, so then that means one subarray I have considered, so now my count should become 1, right? And here I didn't start a subarray, so here the count will remain the same, that is 0, right? Now again, for this index 2, again we are having two choices. One is that we include it. If we include it, then our index will become I plus k, that is 2 plus 2, that is 4. I will become 4 and count will become 2 because we have included a subarray, right? And if I don't include it, then I will move to the next index, that is I equals to 3, and my count will be 1 only, right? Then again, for this, I have two choices. If I take it, then my I will become 6 and my count will become 3. And if I don't take it, I will be equals to 5, count will remain the same, right? Now you will see in this particular case, my count has become 3. Then that means the 3 subarrays that I wanted to consider, they are done. So now I shouldn't go further here. I should go back now. So now when I would be going back, when I will backtrack, what I will do is, since now here I have got the answer, there are no further subarrays left to consider, right? So from here, I will return a 0, right? So this is going to be one of the base case that if the count of the subarray becomes equals to 3, right? Then we can return from there, right? So after returning, it will come here, right? Now at this I equals to 4, we had considered a subarray starting at index 4, right? So now we should also know that starting at index 4, what is the sum that the subarray of length k is having? If I have considered that I am starting a subarray at index 4, then this is the subarray, right? I should know what is the sum of this subarray. Only then I will be able to identify that what is the maximum sum that we are getting, right? So one possible way is that from this index, I run a loop till k times in my nums and then find out the sum at each point, but that is going to increase our computation. Instead of this, what we can do is that we can do some pre-processing, right? We can do some pre-computation for identifying that for every index in nums, what will be the sum of the k length subarray if I start a subarray from that particular index. Basically, I will create another array, let's suppose sums. Now this is going to store for each index. So here index 0 will denote that if I start a subarray from index 0 in nums of length k, then what will be the sum of that subarray, right? So if we see, this will be the first subarray, right? Its sum is 3. So we will store a 3 over here. Then next subarray will be this. And then we will keep on moving our subarray. So if you see, for finding out this sum, we can apply a sliding window approach because initially our subarray was this and its sum is here. Now when we will move on, our subarray will be this. A new element will be added and a previous element will be removed, right? So out of the sum of this subarray, that was 3, we can add this number which is being added and we can subtract this number which is being removed. So 3 plus 1 will be 4 and 4 minus 1 will be 3, right? Now for the next subarray, from 3 we will add 2, so it will become 5, and we will deduct 2, so it will remain 3, right? Then next will be this one. So from 3 we will subtract 1, so it will become 2, and we will add 6, so it will become 8, right? And then similarly it will be 13, next will be 12, and then for this subarray it will be 6, right? And then we'll stop. These are the indices 0, 1, 2, 3, 4, 5, 6, right? See, this is the last subarray, right? There cannot be a subarray of length k that can start at this particular index, right? So the size of this sums array will be equals to the number of subarrays of length k that you can get out of this nums array, right? Which will be equals to nums dot size minus k plus 1. This will be the total subarrays that you can get, right? See here, what is the size of sums? It is 7. 7 are the total number of subarrays that you can get. The size of nums was 8. 8 minus 2 plus 1. So it will be 7, right? So now that I have the sums over here. So when I had started a subarray at index 4, so I know that the sum of that subarray is 13. At the index 4, it is 13, right? So we will have a 13, and in this 13, we will add whatever we have got from this, right? So this is returning a 0. So it will be 13 plus 0, that is 13, right? And then from here, it will just take whatever it is returning, because see, in this path, we have included the current subarray starting at I equals to 4. So whatever is the sum of that subarray, we need to consider it. But here we are excluding it. We are not starting any subarray at index 4. So that is why here we are not going to add anything. Whatever it is returning, we will consider that, right? So if we come to this particular path, so here again we will have two choices. When we have included this, so our I will become 7 and count will become 3, and we have not included it, I will be 6 and C will be 2, right? So now here you will see that the count has become 3 now, right? So we will return from here and it will return a 0. And we have started a subarray at index 5. At index 5, the sum that we have is 12, right? So here we will have 12 plus 0, that is 12, right? And then here again, I equals to 6, C equals to 2. We will have two choices. Here I will become 8, C will become 3. Here it will be I equals to 7, C equals to 2. Now here C equals to 3, and also we have crossed the limits of our sums. So we are going to return a 0 from here, right? And then at index I, the sum that we had was 6, right? So it will be 6 plus 0, that is 6. Now from here, if you see, although the count is 2, but our I is equals to 7. We do not have an index I over here, right? From index 7, we cannot start a subarray of length k, right? So we will have to put a check, right? We'll have to put a check that if this index cross the limits of our sums index, then we will return, right? So basically we are having two base case over here, that if our count becomes equals to 3, or if the index crosses the limits of sums, in both the cases we can return a 0, right? So now for this, from the left side we got 6 and from the right side we had got 0, right? So now since we need to find out the maximum sum, we will take the max of these two and this will be returned, right? So the max of these two will be 6, so 6 will be returned from here. Now at this particular point, from left it got 12 and from right it got 6, so we will take a max of it and then we will return, right? So the max of it will be 12, so this is going to return 12. Now here from the left it got 13 and from here it has got 12, right? So what it is going to return? It is going to return 13, which is the larger one. And then here at index 2, we had considered a subarray. The sum over here is 3. So we will have a 3 over here and 13 is returned. So 3 plus 13 will be equals to 16. And then something will be returned from here. So we'll take a max of those two and we will return. And then from this tree also there will be something that will be returned, and then we will take a max of it, and then at this point, at the initial point, we will be having the maximum sum of our three non-overlapping subarrays, right? And also if you see over here in this tree, if you see, there are sub problems that are being calculated. If you see here, I was 1 and C was 0. So when you move on to the next, here I will become 3 and C will become 1, right? If you see, this is the same problem that we are solving here, right? So we are having same sub problems that are being solved. So for that, we can use memoization, right? We can use a 2D DP. Why 2D DP? Because if you see, there are two things that are changing here. One is the index I and other is the count of subarrays, right? So we will take a 2D DP. What will be its size? So first thing will be N. N basically will denote the number of subarrays that you can get, right? The number of subarrays of length k that you can get, which was nothing but nums dot size minus k plus 1. And what will be the count? Count we can keep as 4. Why 4? Because our count is going to be 0, 1, 2, 3, right? That is the reason 4. So we can take a 2D DP of size n cross 4 and we can cache the results of this so that we can write an efficient code, right? So now coming back to what we have got. We have got the maximum sum of our three non-overlapping subarrays. So basically, as I told you earlier, that these were the three subarrays that we had, right? Their sum was 23. So this 23 is what you have got here, right? But this is not what we need to return. We needed to return the starting indices of our subarrays, right? So now we will have to do something else also along with this to identify that what all are those subarrays. So now that I have the maximum sum of all these subarrays, can I go into nums and identify the starting indices? So if let's suppose this particular function is a function named get max sum, right? And it is getting an index I and the count. This is C, right? So this is my function, right? So what I can do is that in my array sums for each index, I can see that which index is giving me the maximum sum. See, basically what I can do is that in this, for every index, again, I will be having two choices. The first choice will be that I included, right? And the second choice is that I exclude it, right? So for each index, when I will be having this value, basically, let's suppose this include is giving me that if I consider this particular index, then what is the sum that I'm getting? And if I exclude this, then what is the sum that we are getting? So whenever my include, right? Whenever include is giving me a sum that is greater than exclude, then I will include that index, right? Whenever this include will give me a sum greater than exclude, then I will include this index in my answer, right? So basically we can create an answer vector, right? It will be of size 3, and in this we can store our answer, right? So whenever including that particular index is giving me a sum greater than the scenario where I am not including this, so I will include this particular index in my answer. So if let us suppose if I am starting a subarray at index 0 is giving me a sum greater if I consider from index 1, then in my answer, I will put the index 0 and I will increment my index to I plus k, right? Because at this index I, we have considered a subarray, right? But if this include is giving me a sum smaller than exclude, so then that means I will have to move my I forward because this index is not giving me a maximum sum. And now other thing is when both of these give you the same sum. So if you will see in the sums, this subarray and this subarray, both will give you the sum as 3, right? So for index 0, in include also for this subarray, you will get the sum as 23. And for exclude also, you will get a sum as 23. Now in this particular case, what you will do? Are you going to include it or not? We are going to include it. Why? Because whenever there are multiple answers possible, we need to return the lexicographically smallest one, right? So that is the reason we will include here itself. Because if we will exclude it, then we will move forward. We will do I plus plus and we will get a index which will come later on, right? So that is why we will include it here itself, right? And as soon as we have got our three indices, we will stop, right? So basically we can run a while loop that while our I is within this range and our answer's length is less than 3, we can keep on finding the answer, right? Now, how will you identify that for an index I, including it, what sum you are getting and excluding it, what sum you are getting? So this is the function. See, this entire thing we had done to find out these particular things only. When I am including it, what I will do? I will take what is the sum at that particular index. So in my sums vector at the index I, whatever it is, I will take it and then I'll call my get max sum function, right? And now what am I going to pass in this? So this was receiving an I and a count. What will be the I? So now I have taken one subarray over here, right? I have taken one subarray over here. This is include scenario, right? So that is why I will give I as I plus k, right? And what will be the count of subarrays? So it will be my answer dot size plus 1, whatever is the size right now, that size, and since I am including this subarray, so plus 1 for that. So this is what we are going to pass. And if we are excluding it, so from sums we won't take anything. We will just call our get max sum function. What will be the I? I will be plus 1 because we are excluding it, and the count will be answer dot size, whatever it is, right? And then if the include is coming out to be greater than equals to exclude, then we will push that index in answer and we will do I equals to I plus k. Otherwise, we'll just do I plus plus and at the end we can return this answer, right? Now you must be thinking that first we did a recursion with this get max sum function, and then we are again for each of the index identifying this answer by checking for all of those, and then again we are calling this get max sum function. So this is inefficient, but no, it is not. If you remember, in this get max function, we are caching our results. We have done memoization. We took a DP vector, right? We took a 2D DP, right? Which is storing our answers. So whenever this will be called, it will not go all the way to the down and then come back. No, it will take the result from the 2D DP and it will return us. So it will be like a constant operation, right? So this won't be taking much time, right? So here in this recursion, we would be building our DP vector, right? And what was the size of our DP? It was n cross 4, right? What was the n? N was equals to the total number of subarrays that we have. Let's suppose k is 1 in the worst case, then it will be equals to n, the total number of subarrays, right? So we can say that for this recursion get max function, the time complexity will be equals to order of n into 4, which is near about to order of n, right? And what will be the space complexity? So here we would be using a sums array for storing the answers, right? And then there will be a stack in our recursion as well. So we can say that the space complexity will be order of n, right? So this is a bit clumsy. Let us just quickly look at the code to understand the approach. So first of all, for our pre-computation, we will create a vector named sums. This will store the sum of each subarray starting at a particular index, right? And then first we will identify the sum for the first window, right? Or for the first subarray. So for that, let's take a variable sum, right? Now we'll run a for loop of I starting from 0 and I less than k, I plus plus, right? Inside this, in the sum, we will add nums of I. With this, we will get the sum of the first subarray, right? So in our sums vector, we can push back this sum. Now that we have got this, now we will move our sliding window one index forward and we will keep on adding and subtracting the numbers from the previous sum, right? So this loop was running from I equals to 0 till less than k, right? So the next loop will start from I equals to k and we can go till I less than nums dot size and then we'll do I plus plus, right? Now inside this, in the sums, what are we going to push back? So what is going to be the new sum? Whatever is the previous sum, in that we are going to add the current number, which is nums of I, and we are going to remove the first element of the previous window, which is nothing but nums of I minus k, right? So first we will take the last sum from sums. So it will be sums of sums dot size minus 1, right? From this sum, I need to remove nums of I minus k and I need to add the current element which is nums of I, right? So with this, I will get my pre-computed sums vector, right? Now that I have got it, I need to find out the maximum sum by doing my recursion, right? So what I will do is that I'll create a function get max sum, right? Let's see what all are we going to pass in this. So let me create this function here. We will name it get max sum. Now what all is it going to receive? So first it will obviously receive the sums vector because we need to know that what is the sum for each of the subarray. Then whatever is the k that is given to us in the input, and then the two variables which will be changing, that is the index and the count, right? So now inside this, what is going to be our base condition? So I told you that there are two base conditions. One is that if the count become equals to 3, and the other is that there are no subarrays left. So if the index becomes greater than equals to sums dot size, right? If this is the case, then we will return 0. This is our base case, right? Otherwise, we will perform recursion and we will identify that what is the sum that we are getting if we start a subarray from this particular index or if we don't, right? So one will be include, that is we are starting a subarray from here, and one will be exclude, right? So in include, since we are including, we will take the sum from the sums vector at the index end, and then we will call the recursive function get max sum. Now inside this, sums will be passed as is K will be passed as is. What will be the new index? The new index will be index plus K, and the count will be count plus 1, right? And then for exclude, we will simply call the recursive function get max sum. Sums will be passed as is, K will remain as is, index will be incremented by 1, and the count will remain as is, right? And once you have got these, we just need to return the max of these two, right? So with this, we will be able to identify that what is the maximum sum, right? So now since this is going to take a lot of time, let's memorize it. For memorization, here what we'll do is that we'll create a 2D DP. For 2D DP, what is the size that we will create? It will be the number of subarrays of length k that we can have into 4, right? So first, the number of subarrays that can be created will be nums dot size minus k plus 1, right? So we'll create a vector of vector named dp. Its size will be n cross 4, right? And initially we can keep all the values as minus 1. And now we will pass all these things inside the getMax sum function. So firstly, it was receiving the sums vector, right? Then it is receiving k, then the index which will initially be 0, count which will be initially 0, and then the dp vector. So here now we can receive this dp vector, right? And then here we will have to pass it. Before returning, we will update it in dp. In the dp at the index end comma count, we will update it, right? And then here before calling the recursive function, we will check that if the dp of index comma count is not equals to minus 1, then return dp of index comma count. So with this, we will memorize our function, right? So once we have done this, now we need to identify our indices, which will eventually be our answer, right? So for that, what we'll do is we'll create another function. Let's suppose get answer. This will give us the indices vector, right? So we can directly return this, right? Now, what all is it going to receive? So let's see. So first of all, it is going to give us a vector, right? Its name is get answer, right? Now inside this, what all are we going to do? So first we need a vector for our answer, right? Then we will start from index I equals to 0. We will check for all the indices in the sums vector, right? So definitely we will be needing the vector sum over here, right? Vector sums, right? And then obviously we will need the integer k for identifying the length, right? So once we have got this, we will run a for loop that while our I is less than sums dot size, and there is another condition that we have to put, that answer dot size is less than 3, because as soon as we get the 3 subarrays, we need to stop, right? So now that we are running this loop, we need to check that for the current index I, after including it, is it giving us a larger sum as compared to when we are excluding it, right? So again, we will take an include and we will take an exclude, right? So when you are including it, you will take sums of I, right? And then you will again call your get max sum function, right? So this get max sum function was receiving the sums vector, then k, and then the index. So now that you have included this index I, what is the index that you will pass? It will be I plus k, right? And what will be the count? Count will be answer dot size plus 1, right? And then we also need to pass the dp vector. And in exclude, we will call the get max sum function. We'll pass sums as is, k as is, I will be I plus 1, count will be answer dot size, and we'll pass the dp vector, right? So once you have got these two, we will check that if include is greater than equals to exclude, right? So equals to we need to keep for lexicographically smallest thing, right? So if it is, then in our answer we will push back the index I, and now our index will be incremented by k. Otherwise, if including this is not giving us a maximum sum, we will increment our I by 1, right? And then from here we can simply return this answer, right? So here for calling the get max function, we would also need the dp vector, right? So we will also receive the dp vector over here. I think these are the only three things that we need for this. So here in get answer, we will pass sums, we will pass k, and we will pass the dp vector, right? And whatever it will give us the three indices in our answer, that vector we will return. So this is what our code looks like. So this is what our entire code looks like. Let's run this. So this has to be an integer, right? Since we are returning an integer. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.